Hello class, Mr. Newell here. This is April 15th. We are continuing our statistics. Today we're going to learn about box and whisker plots and also how statistics can be quite misleading. So lots of neat stuff in today's video. So follow along, pause when needed to think about questions I ask, and hope you'll learn a lot right here. Okay, so this is the day 4 video of the day 4 of statistics for April 15th. And I'm trying to round the screen with my finger. I'm waiting for a stylus I ordered. But today we're gonna learn about box and whisker plots. Okay, and of course right here is a box and whisker plot. But first of all, before we get into that, let's look over here at this graph on this part. It says life expectancy at birth. And there's a bunch of countries listed here. Oops, we lost that. There's a bunch of countries. These countries all start with the letter A. So this isn't all the countries in the world, just the ones that start with A. And here's how long you'd be expected to live based on the country you lived in. And if you're a male, you look here. And if you're female, you look here. So look at the countries, look at the ages, male and female. What do you notice? Let me go ahead and pause the video for a moment if you like. Okay, welcome back. So one thing you notice, who lived longer, males or females? Overall, it seems that the females actually live longer. And also, you notice different countries have different ages. So if we said, what is the average? And so let's just look at the females. We could do the males, but let's look at the females. Over here it says female life expectancy. So looking at this big list of numbers right here, we'll just kind of look at that big list there and say, okay, what is the lowest number in this list? And the lowest is 40. Unfortunately, in this country, Angola, if you're a female, the average life expectancy, in other words, the median age, or using the median, is only like 40 years old. That's not very good. That's the lowest number in the list. And in fact, we took all these numbers and we wrote them all here in order. 40. The highest number on the list was 80 in Albania. If you're a female, you lived at 80 years old. And that's in this list also. Wait, that's not the highest number. We got 87, sorry. 87 is the oldest list. So taking these numbers, we put them all in order. Now here I'm making a box and whisker plot. So to make a box and whisker plot, this is what you're gonna do. Make yourself a number line. Don't just look at these, don't just look at the regular numbers, don't skip any numbers, 40, 45, 50, make sure you put everything all the way across. Then from there, our lowest number, and I put them all in order, 40 was the lowest number. So where 40 is, this is our minimum, we'll put a line right there. See that little line? We put a little line right there. And then we go to the top of our list, 87, that was this number right here. That's the maximum, that's the oldest. So here's 85, so 87's about right there. We put a little line. So this is how we're going to create the box and whisker plot. And then we're going to look at the median. What is the middle of this list? So when I look at the middle, I started counting in. Cross these off. Let's go all the way to the median or middle. So as we cross them off, 5, 5, 6, 6. Okay, oh, we've got 2 numbers in the middle. So if you ever have that happen, if you don't have a number all by itself, then you're going to look exactly in between those 2 numbers. Well, between 80 and 80 would be just 80. Okay, so our median is 80. So we put that right here. 80, here's 80, so we give it a line. So remember, we did the lowest, 40, gave it a line. We did the highest, maximum, 87, give it a line. We found the exact middle, median, we put a line here. So do you notice that the people that live older than the median, half the people are older than 80, but do they live a lot older than 80? And the people that live less than 80, do they live a lot less than 80 or a little bit? So here's the next little piece of data we can do. This was our middle, right here was the median. So that was right here, the median, we put a line there. So let's look at everybody that lives less than the median. That's these numbers right here. What is the median of the people less than the median? In other words, of all these people here that live less than 80, how much less than 80? Do they live just 2 years old? Let's find the median of the people less than the median. So looking in this list right here, if we cross off 3 numbers and 3 numbers, 75 is the middle of the lower numbers. So I'm going to put that right here. Here's 75. We're going to give it a line. It says Q1. Q1's right here. Q1 stands for quartile 1, 75. Okay, we call that quartile 1. Likewise, let's look at the people that are over 80. Everybody that's above the median. Don't include the actual median number. This 80 is actually past the median. So all these numbers, there's 7 numbers again. Let's cross off, find our middle, right there, 82. 82 is the middle of the people over 80. So here's 82, about right here. We call that Q3, or third quartile, 82. You might say, okay, quartile 1, quartile 3. Well, what happened to quartile 2? I got Q1 and Q3. Where's Q2? Ah, it's right here. The median, color, the median is actually Q2. Okay, so what's the purpose of this? Let me clear this out again. So you might notice we got these 5 numbers. These are your key 5 numbers. You put the lowest number, 40. That's the minimum. You take the next number, quartile 1, 75, right there. You take the next number, the median, 80, right there. The next number, the third quartile, 82, right there. And then, of course, we've got the final, the maximum, 87, right here. So what this does is it divides the people into 4 groups. We've got 4 groups, or 4 quartiles. Remember, quartile means quarter, means 1/4. So by doing this, we've created 4 groups. In fact, let's look at, here's the 4 groups. Notice we've got a group of people, oops, we lost our pen. We got a group of people here, a group of people here, a group of people here, and a group of people here. Try that again. Okay, here's the median. Here's the exact middle. Median is 80 years old. Notice half the people live older than 80 and half the people live less than 80. Do the people live older than 80 live a lot older than 80? Do they live to be 200? No. We got a line here and a line here. There's a group here and a group here. Likewise, people below 80, do they live a lot less? Well, there's a line here and a line here. Boom, boom. Notice we've divided the people into 4 groups. Each one of these groups has about the same amount of people. 1/4 of the people, I draw 1/4. 1/4 of the people live between 40 and 75. 1/4 of the people, 1/4 of the countries. Try to do that. 1/4 of people live between 75 and 80. If you live older than 80, you're going to live a lot older? No. 1/4 of them are right in here. 1/4 of them are between 80 and 82, and the other 1/4 are between 82 and 85. So one thing is that you can see is that maybe you live older than 80, but you don't live a lot older than 80. If you live less than 80, you might live a lot less than 80. So we've divided, once again, the groups into 1, 2, 3, 4 groups. People over an 80, not much. So the box and whisker plot kind of gives you a visual. Let's learn a little bit more about this. Next page. Okay, so here's a try it. We'll do this kind of together. It says, can you find each measure below using only a box and whisker plot? So wait, let's go back to this box and whisker plot. Okay, when we created this, this was based on the medians, isn't it? We got the youngest, we got the oldest, and we got the middle. I have an airplane flying over. So if you were to look at a box and whisker plot such as this one, Could you just look at this and find the mean? No. But could we look at and find the median? Yeah. Remember, when I look at these numbers, the very, very middle, that's the median. These are based on medians. Do we know the mode? No. We can't figure out which number came up most often. And range, this is not domain and range, but could you tell what's the spread of the numbers? Sure, we could see how far it is from the lowest number to the highest number. 66 to 75 is the range of numbers here. Okay, so let's see, what are we looking at here? So for this question, you could figure out the median and range, but you can't figure out the mode or the mean. Okay, here's a graph of 20 players on the soccer team. And these are their heights. And it says players' heights. And they made a graph. And once again, we get these 5 pieces of data. Do you know the minimum height of a player on the team? Yeah, it's right here, 66. This is the first number. This is your minimum, 66. Trying to write with my finger. Do we know the first quartile? Yeah, that's the first line. That's 67. Do we know the median? Oh, that's the next line, 69. In other words, the middle height on the team was 69 inches. Third quartile, right here, 72. And the maximum, the last number, 75. So once again, let's look at the players on the team interpreting this. Of all the players on the soccer team, there's 20 players. The middle is 69. So I'm assuming like 10 players are down here and 10 players are up here. In fact, of the players down here, are the people higher than 69? Are they just a little bit over 69? No. About 5 of them are probably right here. And 5 of them are right here. So 1/4 of the players are between 69 and 72. 1/4 of the players are between 72 and 75. They're really tall. 1/4 of the players are below, between 67 and 69. And 1/4 of the players are right in here. So this is probably also 5 players and 5 players. They're just between 66 and 67. So once again, it's neat. Box and Whisker divides you into 1, 2, 3, 4 groups. That's why I call them quartiles. Remember, the median is really just another way to say quartile too. So now you try to answer these questions down here. This is multiple choice. Have you paused the video? Which one of these is true? Or is more than one true? Okay, pause the video and I'll be right back. Okay, you should be back. Okay, so for these, let's see. Let's look at the first one. The mean height is 69. Wait, we can't do mean. Box and Whisker only works with medians, right? It only just looks at the middle numbers. Okay, next clue. Half of the players are between 67 and 72. Well, let's see. Remember, each little quartile is 1/4 of the players. 1/4, 1/4, 1/4. So are half the players between 67 and 72? Actually, that's true. This is half the people. So my box is getting a little messy here. Clean that up so we can see it. So 67 and 72, yeah, that's half the people because this is 1/4 and this is 1/4. They're all quartiles. So that one is true. Well, let's see, are these others true? The height of the shortest player is 67. No, the shortest player is 66. There's the shortest. So this one's wrong. And the last question, the range of the players is 5 inches. That means from the shortest person to the tallest person. Is that 5 inches? No, that's not 5 inches. What's that, 9 inches. So it's choice B. Okay, next slide. Feel free to pause the video whenever you want. Okay, so here comes the next slide. Okay, so take a look at this one, multiple choice again, but you're trying to look at the heights of the baseball players. And just to remind you, 6 feet, 6 times 12 is 72 inches. Okay, that can help you out. Okay, look at the choices. Which one of these is not true, that you're not sure about? Okay, go ahead and pause the video while you think about it before I give you the answers. Okay, welcome back from your pause. Let's see. The first one, the range of the players is 7 inches. Is it 7 inches from the shortest to the tallest? Okay, don't look at 70, nobody's there. Here's the first person, 71, 78. From 71 to 78, that is 7 inches. So that one's true, okay? So, but we're finding out which one can you not conclude, which one's wrong. Okay, go to the next clue. Let's clean this up a little so we can read it. Okay, at least 30 players are 6 feet tall. Okay, wait, 6 feet tall is 72 inches. Well, how do we know 30 players? Wait, up here it says there's 40 players. And these are grouped into fourths. So if there's 40 players, there must be 10, 10, 10, and 10. So are 30 players 6 feet tall? So 6 feet tall would be right here, or taller. That's all of these. So that's 10, 20, 10, 10. That's 10, 20, 30. That is true. Only 10 of the players are under 6 feet. This is a tall baseball team. Okay, next clue. The mean height of the, whoa, wait a minute. The mean height 74. Okay, I do see 74, but is that the mean? No, Box and Whisker only tells you about median. Sorry, I can't write with my finger. So this is the one that's messed up. Lastly, let's just see if there's another one. 1/4 of the players are at least 6'3". 6'3". 6 foot is 72 inches. So 72 plus 3 is 75 inches. Are at least 1/4 of the players 75 inches? Yes, right in here. Here's 75. That's 10 of the players. 10 out of 40, of course, is 1/4. That one is true. So C is the one that fails. Okay, so I'm going to clear that out just so you can see it again. Okay, next slide. Feel free to pause whenever you want. Ah, this is a neat slide. The paired Box and Whisker plot shows the test scores from 2 different classes. Okay, this is a neat question. There's 2 classes. It says A period and G period. Let's call this first period and second period. And this could be your math class. And these are the teacher's percentages. Here's the scores that the teacher looked at the grades in the class. Which class would you prefer to be in? Do you want to be in first period? Here's their scores. Or do you want to be in second period? Here's their scores. Go ahead and pause the video while you think about it. Okay, welcome back. This would be fun if we were in class and you're all debating here. But yeah, here's first period, here's second period. Well, it's really kind of up to you what you would like to be in. I noticed in second period, 1/4 of the students have are down in here like at a D, aren't they? Oh, but if you look in first period, their lowest grade is what, right here, 72. Nobody has lower than a C, don't they? So maybe I'd be in first period. Yeah, because look, second period, I could be one of these people right in here. I don't want to be one of those people. So do you want to be in first period? Wait a minute. Does first period have any A's? We need 90 to 95. There's nobody over here with an A. Second period's got 1/4 of the class is up here in A's. Well, actually, some of them are a little bit below. So I know second period people are all over the place. The class median in second period is 82, while in period 1, the class median is 80. In period 1, you probably say the median's 80. Most of the people are really, really close to it. There's only a few people just up in here and up in here. But in period 2, there's people all over the place, aren't they? So it's really kind of your opinion of which class you'd like to be in. Okay, next slide. Ah, okay, this is something different. Okay, here's a neat question that we're actually facing right now at our school. It says, school administrators are thinking about starting and ending the school day 1 hour later. Huh, sounds familiar. So they did a survey and they asked students. And over here, they asked the student, are you an athlete or a non-athlete? This student says, I'm an athlete. You agree or disagree? They say, I agree. In other words, they want to start school 1 hour later. And they asked the next student. He said, I'm an athlete also, but I disagree. I don't want to start an hour later. And they asked the next student, I'm not an athlete. I'm not on a sports team. I'm in something else. And they're like, oh, I agree. I like to start an hour later. And on and on and on. They went all the way through the list. So what do you think? What did the people say? Well, let's add them up. And we did that over here. What is the ratio of agree to disagree? Okay, so of all the athletes, here's what they said. 10 of the athletes said, yes, I want to start an hour later. They agree. And 6 said no. While in the other group, the non-athletes, 5 of them said yes, agree, and 3 said disagree. Is there a difference in answers between athletes and non-athletes? You can pause and think about it. Actually, it's the same. If you compare these, 10 yes and 6 no is actually the same as 5 yes and 3 no, isn't it? It's exactly the same ratio. Remember, we can do a little cross multiply trick. That fraction, 30, that fraction, 30, they're actually the same percentages. So they said, well, we need to do a bigger survey. That's not enough. Let's ask more people. So now they asked a bigger group. Here's what they said. What do you think now? Is there a difference between athletes? Is there a difference between athletes and non-athletes? Go ahead and pause the video, see what you think. Okay, let me bring this down a little bit. Here's the data again. Get that off of there. Okay, this is just the chart again with the totals. Okay, well, I notice they did ask, here's the athletes. There were 75 athletes. 31 agree, 44 disagree. Oh, the athletes, more of them disagree, don't they? Well, the non-athletes, we have 23 agree, 19 disagree. More of them disagree, so, or more of them agree, okay? So it seems like the athletes don't like it and the non-athletes do. So there's a difference. Over here's the totals. They said, how many people agree altogether? 54. How many people disagree altogether? 63. So you can see the totals for the school. So what is the ratio of agree to disagree? We can say athletes. We could say 31. A lot of people like to use a colon to write this. They say 31 to 44. We could do the next group. Try and get another color. There we go. Non-athletes, we would say 23 to 19. Okay. And total students, we can say overall the school, 54 said yes, we want to start an hour later, and 63 say no. So this is a way we can write a ratio. You can also write as a fraction. Let's go farther down. Okay, and think about the answers to these 3 questions. Go ahead, pause the video while I wait for you. Okay, so let's get our answers here. Clear this out again. Okay, so let's answer this first question. What percent of all the students agree? Let's look at all the students. We had 54 agree out of, what is the total? Out of 117 students. I put that on my calculator, it said 0.46 or 46%. That's less than half. And of course you can see, comparing these numbers, yeah, less than half the students were in favor of this. Next question, what conclusions? Well, it looks like overall students aren't really for starting an hour later, according to this survey. And last question, Does being an athlete affect how one might vote? Well, yes. We can see the athletes were more against it. They didn't like it. Okay. They were really upset. They were mad, right? They were really upset about it. Okay. Hey, next page. Okay. Now we're going to talk about association, also called correlation. So you got to read this here. In a survey, non-athletes were more likely than athletes to agree with the statement. For this reason, you can say there's an association between the two types of students. It seems being an athlete affects your response, or being a non-athlete affects your response. There's an association. That means there's like some type of connection between their answers. Often variables have no association. If the percent of athletes and non-athletes who agreed with the statement were not significantly different, you could say the two variables are non-associated or independent. Independent means separate. If you found no difference between whether you're an athlete or non-athlete, you'd probably say, it doesn't matter. But here it seemed to matter. So if it mattered, we say there's an association. If it didn't seem to matter, we say it's independent or separate. Okay, sometimes we wonder, is the association a causation? Did it cause it? Or is it just a coincidence or related by some other reason? For example, this is a true statement. What do you think? I put, for example, more people are killed in low-priced cars than expensive cars. That's a fact. What did you conclude there? I put, why is that? Why are more people killed in low-priced cars than expensive cars? Are low-priced cars less safe? Or is there some other reason? Go ahead and pause the video and think about it. Talk about it with someone in your house. Okay, welcome back from pause. Hopefully you've thought about the answer. Don't just listen for me to give the answer. I want you to do the thinking. So it's true, more people are killed in these low-priced cars. Does that mean there's less safe? Not necessarily. Is this the cause? Is the car being low price is what causes you to be killed? Is the low price causing you to get killed? No. Here's a hint. Why do young people pay more for car insurance? When you get your first car and you have to get car insurance, it's going to cost a lot of money. While somebody older, like your parents or me, we only have to pay a little bit of money. Why is that? Well, young people have more accidents because you don't have as much experience driving and you're more likely to get killed. You don't want that to happen because you don't have the experience until, with anything, as you practice, you get better. Okay, so it's more that young people are the ones more likely to die. Older drivers don't get killed as much. So then what about this statement? More people are killed in low-priced cars. If you're a young person and you're getting your first car, what type of car would you buy? Are you going to get a low-priced car? Or can you just go out and buy that Ferrari or Mercedes or something like that? When you're young, you're probably going to get a low-priced car. In fact, you might get a hand-me-down, or your parents say, hey, here's an old car from grandma. You can drive this one. It's low price. And that's why more people are killing low-priced cars. To buy an expensive car, you're probably older. You've probably been working a long time and made lots and lots of money to buy that expensive car. And by then, you've got a lot of experience. You might even be, let's see, if you buy an expensive car, maybe you went to college and you have lots of money, which means you're really educated. So you're probably like really smart person. And then if you're smart, you probably drive a lot safer. You probably know all the rules of the road and how to be careful. And that's really the connection. So it's not that the car is low price is the cause. It's related by, as we would say, it's another reason. And sometimes it's just a coincidence, but this wasn't a coincidence. Next slide. Okay, this one's kind of fun. Go ahead and read this here. A teacher recorded the gender of 100 students, means like boy or girl, and whether or not they were wearing a watch. The teacher just wondering how many people are wearing a watch. And so look at our chart here. Here's the males. We can go either way. Let's go this way. 13 of the males are wearing a watch. Well, 14 weren't wearing a watch. Okay, so most of the boys are not wearing a watch. So then we looked at the females. 9 and 34. 9 of the females are wearing a watch, 34 are not wearing a watch. And then we have the total of the class. So first question, which gender was more likely to wear a watch, males or females? Go ahead and pause the video. I want you to figure that out. Okay, so here's the ratios. For the males, I added this up to get 57 boys. 13 of the 57 boys on my calculator, I rounded that. It says 23% of the boys are wearing watches. Well, the females, I added that up. That's 43 girls. 9 girls out of 43, that's 21%. So more boys are wearing watches than girls. Not much, but it is more. So then, here comes Zort. Zort, the unwise wizard, says, on average, males do not live as long as females. That's true. This is because more males wear watches. If you want to live longer, don't wear a watch. Do you agree with Zort? So think about it. I can see more males wear watches than females, and males don't live as long. And that's because if you want to live longer, don't wear a watch. Do you agree with Zort? So this reminds us back to this. Is it a cause, a coincidence, or is there some other reason? So this is where people can use data to deceive you. It's true that males don't live as long as females, but is it because of the watch? No. This is just a coincidence, right? It's just a coincidence. There's no association. Yet people will often do studies and conclude things incorrectly. And a lot of that has to do with what we're doing now with the virus. We're trying to figure out what affects the virus. Is it a coincidence or is there a real effect? Let's go to the next slide. Here's another fun slide. Look at the chart over here. This is really interesting. Here's a table of several countries' life expectancies, along with the number of televisions per 1,000 people. So in other words, if we look at Argentina, they live to be 75.3 years old on average. And there are 201 TVs for every 1,000 people. Okay, go ahead and pause it. Look at the big list and anything you notice. Okay, so it seems if I'm looking at this list, let me circle a few of these things here for you. Let me find the countries they live a long time. Bermuda, and they've got 1,000 TVs for every 1,000 people. In Australia, they got 500 TVs. In Canada, they live 655 TVs. Here's France. In Germany, they got a lot of TVs. Here's Hong Kong and Iceland, not quite as much. Here's some other countries with big ages. Here's some more. And here's some more. Here's an 80s, and there's their TVs. Okay. And let's look at a few others. Let's find the countries where they don't live long. Oh my God, Ethiopia. Well, they only have 9 TVs. Okay. And India, 64. Well, they only have 58 TVs. And well, okay, Egypt, 71, 99 TVs. It seems that if there are more TVs, the people live longer. Countries without many TVs, they don't live that long. Therefore, we should supply people with TVs instead of doctors. So I know how we're going to help out the people in these countries to live longer. We're going to send them TVs. They don't need more doctors. Do you agree with this conclusion? Go ahead and think about it. You can pause if you want. Okay, welcome back. Huh? I got 3 eyes. Okay, I'm kind of confused. Huh? Yeah, the data seems to support that there definitely is an association between TVs and life expectancy. There's definitely some type of connection, but we should be careful. Is it just a coincidence, or is it really a cause and effect, or is it the TVs that are making them live longer? Tell me, why do you think having TVs is making people live longer? Okay, go ahead and think about it. Okay, welcome back. Is it the TVs that are making them live longer? No. But in these countries where they live longer, they've got a lot of TVs, don't they? Oh, here's another short country I just saw. Brazil, 72, 196. Yeah. Well, if they have, here's more probably the reason. If they've got a lot of TVs, what do you need to have a TV? To have a TV, you probably have electricity, don't you? And if everybody's got TVs, there's probably lots of money going around. And if there's lots of electricity and money, they probably have hospitals also, don't they? If they have hospitals, they probably have doctors. Okay, so the TV is actually an indication of money. The countries where they don't have the TVs, like in here, it's because there's not much money. If there's not much money, they can't afford hospitals and doctors and healthcare. And unfortunately, that's why they're not living long. So you got to really think about what is the cause and effect. So people often do this to mislead you. Next slide. Okay. It's funny, this slide's about the flu. Because of time, we'll skip this slide. If you want to do it on your own, you can. But of the 1,000 people who received the flu vaccine, 149 still got the flu. 402 people did not get the flu vaccine, 68 got the flu. What do you think? It says you can make a table. Do you think the vaccine helped? I'm going to go to the next slide. Okay, and here's the homework. So this is what you get to try. And I'm going to post a picture of this because I don't have the slides here. So just look back on Canvas. I'll have a picture of it. Either look at your book or look at the picture of the problems I associate. Have fun with the stuff. Hopefully you enjoyed the lecture. It would have been more fun with all your guys' feedback.